getting started with Python and DynamoDB from someone who just got started. So that sounds kind of absurd, but Justin approached me. He's like, "Hey, would you be interested in presenting at the AWS meetup?" And I was like, "I don't really know what I'd present on. I don't work in AWS as much as I used to." And I was like, "I have been working with this DynamoDB with a personal project." He's like, "Cool, that sounds great." So it was a good motivator. I had not worked in it much, so it motivated me to learn it in depth in a really fast pace, which I probably would not have done. So yeah, my name's Hunter McGuire. As mentioned earlier, I am a sales engineer with Trend. I am based in Birmingham as well, and there will be no talk of Trend for the rest of the slides. This is all Python and DynamoDB. I wrote a little application. It's like an asset manager, just to demo all the CRUD operations and some of the helpers and abstractions in the Python AWS Boto3 library that really make working with the service from a programming standpoint much easier and more intuitive than I've found other people have shown on the internet. So we'll kind of jump into that. All right, so who am I? And this is kind of a funny slide, but it's true. These are all points that I want to make. I like to build stuff. I wouldn't say I'm an expert at anything, but you know, I've built Elk stacks, Kafka, automation tools. I just like to build things, manipulate data, and automate processes. So that's kind of what I like to do, what I really enjoy talking with customers. A lot of customers don't realize that all of our products, especially Cloud One, have APIs. So that's where I like to get them interested in and seeing if they can automate more of their processes and get more time back for them. I'm a PowerPoint wizard as of today. I have the most obnoxious slide thanks to this cool feature called Designer in PowerPoint. If it weren't for that, we were just going to have simple GeoCities type PowerPoint presentation. It was going to be bad. So yeah, my idea of building a slide is taking all the decks from marketing and piecing those pictures together. I'm not a developer by trade. I didn't go to school for it, kind of fell into it, just getting into automation. And I say that I would say I'm pretty advanced with Python. But for instance, I know DynamoDB is built off of B-tree, binary search tree, but I don't really know what that means. I don't know about algorithms and data structures and things like that. As well as I'm not a DBA either. SQL has always confused me. Joins and things like that. I've worked with ORMs, object relational mappers, like in Django and SQL Alchemy, things that let you interact with your data in an object-oriented fashion, and that felt much more intuitive. But I've got to say, DynamoDB is really, really cool if you do it right. And when I say do it right, we'll go over some of those paradigm shifts and how to leverage DynamoDB based off of some of the people that built it, how they, after having it in the wild for a while, they realized there are certain design patterns that really shine for its performance and dealing with your data models and access patterns. So let's get into it. So today's agenda, what we're going to be covering, the basic fundamentals of DynamoDB. This is not really a DynamoDB deep dive. It's more interacting with DynamoDB and Boto3 Python. So we'll be discussing basic fundamentals, single table design, and that's kind of the paradigm that I was talking about that some of the people that work with DynamoDB and some of the community have come up with a really cool way of accessing your data and modeling your data. It takes a little more forethought because unlike a relational database, you know, you build out your tables and then you worry about your logic of how you want to access those together later on. Whereas with single table design, you kind of got to have some forethought in how you model your data, and then you can do your logic, or it makes your logic much easier. So we'll talk about Python, Boto3 SDK abstractions. I like to call it helper classes because okay. Can we mute whoever it is?
It's Ben. Ben, can you mute yourself?
Try again. All right, cool. All right, and then the last part of the demo, we'll cover, I just called it Device Manager because I'm clearly creative when it comes to naming things. It's just a little application I built to really go over all the different CRUD operations and querying that you can do with the Loader 3 SDK. So what is DynamoDB? Dynamo is a fully managed NoSQL service provided by AWS, and it is NoSQL. You can think MongoDB is a very popular one. Cassandra is another NoSQL database, and there's many other ones. But it fits in that category of where you're dealing with mostly schemaless, unless you want to have a schema. You can, but you're dealing with dynamic. You can add to these documents or items. The vernacular changes between whatever tech stack you're working with, but essentially you're not limited to having the schema, and you can have more of a dynamic and extensible database and data model using some of these. I like I said, I'm not a DBA, so I don't want to get in and start a rift of what's better, relational model or NoSQL. I like this. It makes sense to me as someone who likes to build things. So that's why I wanted to present it, because I know sometimes new technologies can be a bit daunting. So I want to go over things that I figured out, so that might be a pain point that others can skip. And also, I have all the code, the PowerPoint, all these things in a GitHub repository. I'll share it in the chat at the end. We didn't want to share it at the beginning because of Zoom, and if you join after chat, you don't get to see that. So yeah, it's scalable. I know that I'm not sure to what extent, but I know Amazon.com uses DynamoDB to a huge extent. So obviously, managing the backend for something that large has to be scalable and fast. Usually, you're dealing with out of less than 100 milliseconds for me, just interacting with the application I have, but I'm sure it could be faster if you get closer to the service. And the coolest thing, and I haven't played with this, but I really wanted to mention it because it piqued my interest, and I would think it would others too, is it has fine-grained access control based off IAM. And to the attribute level, and in a DynamoDB table, think of an attribute as like a column in a regular database. So the types, and you can pretty much conditionally grant or deny access down to that level, which is really, really, really cool. So that's something, if you're interested in looking at that, that'd be cool. All right, so let's get to the meetup. This is going to cover the components of a table, which is really the main thing that you're going to work with DynamoDB. And if you look at it, we'll go over some of the attributes and items. So in a table, you have an item or items, and you can think of that as a row in a database. And each of those items has attributes, and you can think of those as columns. So much like a relational database, you have a primary key, a way of accessing that record when you need to. And in relational databases, that could be a GUID or auto-incrementing ID. And to me, the way I think of it is sometimes that's a useless value. You're using it to look it up, but other than that, it has no purpose. Whereas in DynamoDB, you leverage your primary key to access your data, and you can use it for filtering. So that's pretty cool. So by a mandatory is you have to have a partition key in each item. That's a mandatory. And with that, you're pretty much saying you can access that one item at a time. And that's a simple primary key. Now, if you add a sort key, it's called a composite. And when you add that, that's when you get your one-to-many relationships and query capabilities. And here's some of the items or methods that you can call on that sort key. And that's really important because we'll get into kind of that paradigm of single table, but you can think of these partition keys is what they call an item collection. That's like the root of grouping like items, is they would all share the same partition key. And what makes that useful is the way DynamoDB stores your data is it takes a hash of your primary key. So it's going to take a hash of the partition key, or if you have the optional sort key, those two together. So if, let's say, you have an e-commerce site and you're using partition key as maybe account number. So each person, their data on the back end is saved with a partition key of their account number and some other attributes and sort to access that data. Well, that means all of their data is going to be stored together because it's storing on disk with that hash. So it groups your data closer together, and it has some useful query capabilities, whereas like a relational database, you could consider that, in my mind, a wasted attribute to just seek out your data that you want on a per row record. And this kind of highlights, when I say mandatory, this highlights that, as you can see, for all the CRUD operations, get, put, update, and delete, got to have the partition key. You can have an optional sort key, and then for the put and update, where you're actually applying attributes or adding new items or applying values to your attributes, it would require a value. So here on the left, I created two tables in Postgres just to kind of give a visual of how you could compare these. So over here, I have a users and an assets table. And each of those have a schema. I've defined what types they are, and there was a lot of setup involved in that. And on the other side, this is just a little snippet from a data model that I built. It's what my application is based off of. You see that I have the two keys that we discussed, partition key and a sort key. But this probably looks weird, PK and SK. So sure, you could build a DynamoDB table where you were actually defining attribute names and values in your partition key and sort key. But that really limits what you can do with that table. It makes it very specific. But if you go with this approach of just having a single table and you do your schema and make it to where partition key is named PK and sort key is named SK, and you can name whatever you want, but then it's dynamic. I can add whatever I want into that table, and I can use that partition key to group my data. So I could have an application and add on features without having to change the schema of my database. I could add new features, and it would just have different groupings or different sort keys, and the grouping would be by the primary key. And that's kind of weird to visualize. So the next slide, I want to go over it a little bit and then have some questions, because the whole single table access pattern data modeling took me a while to really wrap my head around. And I feel like I'm very unlikely to impress that upon you in one session. So I do want to cover this and offer some time for some questions before we move on. So this is a portion, a data model that I built using Nosql Workbench, which is an application that AWS provides, which allows you to build models so you can kind of work through your access patterns before you start writing some code and some logic. It also allows you to query and work with your data in DynamoDB, the service itself, as well as locally, which is the cool thing. I think, I don't know if people know this, you can actually run DynamoDB local on your computer. You can get it in a binary form. I think it's a Java jar file, or myself, I run it as a Docker container when I'm using it locally. So you can pretty much build your application, write all the logic without having to give AWS any money, which I'm not saying you shouldn't do that, but I think that's pretty cool to actually have development tools which allow you to work directly with the service that you would be working with in production on your local computer. So let's kind of look into this. So here we have our primary key combined with our partition key and our sort key. So in my application, which is an asset manager, I chose to group my data by domain, which makes sense in an organization. Domain is a commonplace with Active Directory. So I chose to use domain. So I am separating my data by domain, and that is my partition key. So every item that I add into my table is going to be grouped into some domain or another, whether it's an asset or a user. And those are the only two types that I have in this current table, because I didn't want to make it too complex. But that's how it's going to be grouped. So this is the idea of an item collection. This serves two purposes. One, got to have a mandatory partition key, and this kind of solves that problem. You're providing a partition key, and then you're also using it to group your data closer. And so that results in faster response times as well as far as accessing that data. So if you look the way I'm doing it, I'm naming it domain : local.com. And this is totally up to you. It's just a delimiter. It's a way of adding more information into that single key that you can access in your application logic. Because obviously, if you're familiar with programming, doing like string formatting, you can split on whatever delimiter you want. So if I know each partition key is going to start with domain : and then I'm going to have my domain, I can leverage that information and split that up. And then I have two pieces of information. I know it's a domain, and I know that domain is local.com. Same for here, and same for really any attribute that you want. I choose to do it this way. So like here, asset. I'm starting my sort key. That's how I'm sorting, by what I call entity type. And that allows me, because of the sort key having methods like begins with, then all I have to do is provide my domain and begins with asset : and I've literally just gotten all of my assets with two values essentially. So that's pretty cool. And that's kind of the mindset of the single table approaches. You're grouping based off primary key, and then the sort key is a subset of data that you want to access. And you can do that further down, like here. The way I'm doing my asset type, I'm doing virtual : server. So I know two things about that asset. It's a virtual VM and it's a server. So that's a weird concept to think about, accessing your data like this, but it's dynamic. Because here, if you think, I don't have, let's say I wanted to add another domain and I want to start adding some different assets, maybe mobile devices or something. I don't have to change my schema. All I have to do is, hey, I add a new item and it gets a different type of sort key. I could have mobile : and whatever the name that I want to give that item. So it's a different way of looking at accessing your data compared to like a relational database where each table gets its own, or each thing gets its own table, and then you overlay your data together with joins and things like that, which can be expensive. So it's a pretty cool way of doing things, and it took me a while to wrap my head around that. So before I move on, I wanted to ask if anyone wants any further clarification on this. I know it's kind of a confusing subject. It was for me, so don't feel bad if you want to know more or have questions. All right. We shall move on. And we'll come back to this visually to look at as I go a little further into the slides. I don't have too many more, but I definitely wanted to cover how I'm grouping my data before I show you the little API application that I built. So Boto3 SDK Helpers, and I call them helpers because really that's what it does. It's an abstraction for you having to do a lot of setup, if you will. I guess Python's pretty cool in that regard, with setup and lack of, where it does it by indentation rather than brackets. For DynamoDB, the SDK has some really good helper classes, and it can take your code and make it so much more intuitive. So let's kind of go over what I mean by that. Up on the top left here, I'm just doing a query. I'm providing a table name, and it has this weird expression. And all the expressions in DynamoDB, they're strings. So that makes it a little more tough because you can't pass like an object to it. You're gonna have to build the string out. And that, yeah, there are shortcomings with that, because some things in DynamoDB, when you're working with some of the classes, you can't always get strings from the object that you're working with, because sometimes it's pointing to a memory, an object in memory, and you can't pull that value. So I had to find some ways to work around it. But with this simple class, the key class, if you look in the condition here, I'm saying #pk equals : domain and begins with sk entity type. That looks really confusing, but what we're doing here is essentially interpolation. If you're familiar with string formatting, we're just injecting variables here with mapping. So pk equals pk, and because that's the attribute, the primary key that I won't use, and sk equals sk. So we have to have names, and then once we have those names defined, we actually have to have values that we pass to these variables that we're building as well, the attribute values. So :domain equals, in this case, domain : local.com. So that's what I want to query for. And that to me is just unintuitive. I just don't like that. But luckily, there's some really good classes in the conditions within Boto 3 that allow you to do some shortcuts around that. So the key class is one of them. So instead of having to write that expression and build this name map and this value map, I can just say the key equals, and I believe that for the primary key, equals is the only method you get, or you'll get some type of error back from the client. So it equals that and. So the and here's the ampersand to do a little shorthand of that, and sk begins with asset. So I'm pretty much accomplishing the same thing without having to build all these attribute name maps and attribute value maps, and it's really succinct in doing it this way. And there was a little tricky thing I had to work with and trying to figure out how to do this dynamically, and we'll get into that. Here, I know that I only have 2 values, so I could write out this and sign because I know how many I have. But if I'm dealing with something that's dynamic like attributes, I don't know how many attributes you may pass me to do an update on an item. So I can't really do a chain of and statements if I was looking to have like compounding and. So yeah, we'll get into a little helper I found, and I'm going to post all this code if anyone wants to see some of those things. So a little overview of the app we'll look at that I built. It lives on an EC2 instance. It's got Docker. It's just running a Flask container, and it has an instance profile, which gives me permissions to access the DynamoDB service in my account. The data model, again, is just root is domain, and then in each domain, there are assets and users. I didn't add authentication into this application because I didn't want to overcomplicate it, but that would be very easy to do with this model. The tools I'll be using, Nosql Workbench, which I mentioned earlier, is a really great tool for working with DynamoDB, both locally and the service itself. VS Code, I don't have to explain that, and Insomnia. Insomnia is a really awesome application from Kong, the people that make Kong Gateway and Kuma Mesh. It's like Postman, but way more simple and intuitive. So I'll be using that. So let's go ahead and drop over to that really quickly. There's the magnificent SM15. All right, cool. So this is Insomnia, and we're going to work with my application because it's just a backend API. Front end is not my thing. So a couple things. I've already built out. All these are just HTTP requests that I've went ahead and built out, so you don't have to see me type or listen to my mechanical keyboard. But I've grouped it by asset endpoints and user endpoints. And that's how you access the items in this application. You hit an asset API endpoint, or you can have a user API endpoint. And one thing to note here, because this probably looks weird, cool thing about Insomnia is it has this concept of environments, which essentially environment variables. So I have 2, which is asset. So you can kind of see the API endpoint that I'm actually hitting. So that's the IP address of my EC2 instance. And then I'm going to API/v1/asset to get my assets, and the same for users to get my users. So let's go ahead and look at some things. So we're just going to go ahead and list all the assets, and I'll just go ahead and send this response. And as I mentioned earlier, it does, in this particular API, I do have to provide the domain, since we have to have that information to access our data. Now, if I had added authentication to this, I could just grab the domain of the user logging in, and then you wouldn't have to provide this in your query requests. But for now, since I didn't want to complicate it, just know that I've already added the query parameter of domain, local or not local. Those are the only 2 I have in here. So yeah, let's go ahead and do a query. All right, so this is going to, and one thing to note, 1.2 seconds seems pretty slow. I guess it's kind of like a Lambda. It has the cold start type thing. So the more requests I do, the faster this is going to get. So I keep doing it now. We're down to 77 milliseconds. So if you start playing around, this seems slow. It's actually not. It just kind of has like a warm up period. So these are all of the assets that I have in this particular domain of local.com. Each asset has these attributes. There's not a constraint at the DynamoDB level. I have a constraint in my Python logic that says if you try to post a new item and it doesn't have all of these keys that I have set in global variables, then you're just going to get a response of 400 bad data. So you're going to see that this returns the same thing. But what you're not seeing is all of those items that I mentioned before. Oops, wrong one. Here. So PK, SK, and entity type. You're not seeing those. Those are backend constructs that whoever would be using his application don't need to know. So I filter those out in the logic in my Python logic. So that's why you're not seeing those things in my response. Now, whenever I was saying that chaining together the and statement posed a problem for me to figure out, the reason is that I wanted to not just be able to list my assets, I wanted to be able to filter on my assets too. And that's where I kind of had to figure out a way of how to deal with that, building an expression that had and compounding ands based off what I supplied. So let's say we want to get, let's see, then there's Hyper-V. That sounds fine. So I can do a query, and then I'm going to get returned back the assets that have those attributes. And the reason why I said chain together, if I want to do a compounding one and say, all right, well, let's get one where, I don't know, the cost center equals 227. Oop, that's doing the decimal. Oh my goodness, what's happening? I don't know why that's not filtering. Demo gods, come on. Cost type. Anyway, we'll get to that. But yeah, I'm chaining together each of these key value pairs that I'm passing in the query parameter, and using that to build an expression, a compounding and. So for each one I do, it's just saying this equals this and this equals this. And let's get an item just to kind of show that we can work directly with an item. In this API, hit the same asset endpoint, and then you just add the item that you want to work directly with, and then that's going to get it. And so for each of these here, post, put, and delete, we're pretty much doing the same thing. We're hitting the asset endpoint, and we're passing the item that we want to work with to either add, update, or delete. So let's look at some code. I don't want to spend too much time on the code. There's too much in here to cover in the session. I feel like I'm already getting to the Q&A point to begin with. And if people want to stay and talk, I'm moving for a little bit. But this is how I created this table. It's pretty straight, simple. You know, I import Boto3. I have my variable name here for my table in case I need to use it again. And then I'm just assigning a variable to a Boto3 resource. You can do a resource, a client, and a session when you're building working with the API. Client's kind of more low level, but when you're working with a resource, and I believe maybe with a session too, you can actually access all the client methods going through the meta class. So resource is good because you get some higher level abstractions, like we can look at with the table. But here I am just saying I want to create a table, and this is the only time I'd have to do this if I built off a single table design. This is all it would take to build a very dynamic table that I could continue to build on and extend. It's really just defining the attributes that I'm passing. So PK is going to be a string. And that's an important thing to note about DynamoDB. It's not dynamically typed. So if you're not using any of the helper classes and you're doing the long way of putting items and updating items, for every value that you pass, you also have to pass what type it is. So you can no longer just simply provide a key and a value. You actually have to provide a key, and you have to provide a value that's a dictionary or a JSON object, if you will, that has the type and the value itself. So using some of the helper classes can really abstract away a lot of that setup that's not necessary. And the helper classes, essentially, they take the type of that you pass with a value, and they just take whatever type that is, and that's what it transfers when it's making the API call. So table name, I'm creating the table name here that I've called device manager, and then I have to define at least a minimum schema of primary key. But in my regard, in this application, I have a primary key and a sort key. And they're called hash and range. So it's kind of synonymous, hash and partition and sort and range. So that's all it takes to get a table built out in a single table design. Obviously, you can change your billing mode. And here, I just want to showcase that there's a waiter that you can use that, once you, sometimes I know creating like an index, like a secondary index can take some time. So I'm not sure if that has a waiter, but I know there's a get waiter for table exists. And that way you can make an API call and then you can know when it's actually created. So, oh man, there's so much code. Let me minimize some of this because there's a lot here, but I do want to highlight just a couple of those helper classes that I discussed before we drop off. And like I said, I'm going to post all this code. And if you want to further discuss it at a later time, I'll have my contact information in there and we can discuss anything you want. But here, if you take anything away from wanting to know about Python and DynamoDB, these 5 classes are really what I would say remember. These are the ones that will make your life like so much easier. So the key we saw earlier, where I'm abstracting away working with the sort key and the partition key. Attr essentially does the same thing, but for working with attributes. It's a different class with different methods. And then the and class is the one that I use to chain together those dynamic and statements rather than having to use the ampersand. Because obviously if I don't know how many key values I'm going to get past its query parameters, I can't have that. So I've got to dynamically build that expression as the request comes in. And then these two, the type deserializer and type serializer, are what I was talking about. And I no longer have to build a map of my value and its type. I just pass my value to the serializer or the deserializer, and it either makes it into the way DynamoDB wants it, or it takes from DynamoDB and it gives it to me in a way that I understand Pythonically. So I don't want to go over too much of this JSON stuff. That's just for encoders. So yeah, as we looked at before, I'm building a resource. And I wanted to highlight this too. So if I were working with my local running DynamoDB instance on Docker or Java, you would just pass in this right here, import URL equals locals, whatever port you have it running on. So that way, if you put that into there, it's not going to reach out to DynamoDB service with Amazon. It's going to do it locally. And one of the constructs that we use from a Dynamo resource is a table. And this is a high-level abstraction. It allows me to do queries on my entire table, do things like scan. So a scan is give me back all of the information in my entire table. So let's say you had one of those simplistic tables that I mentioned that just had a partition key. Well, if you can only get one item at a time, your only option is to get that one item or scan my entire database, give me everything, and then I'll sort it out in the logic of whatever application programming language I'm working with, which is really expensive query. So that's not really a good way of doing that. So, but just know that you can scan everything in your table. And paginator. This is another one that I want to bring up. I believe it's 1 megabyte is the maximum response size you can get from DynamoDB. And the way it works is for the paginator, it takes away the setup that you would have to do to handle that yourself. So what it does is if you had a query and it was more than a megabyte as a response, the response that you received would have a key in your response of last evaluation key. And you use that on your next response, you pass that, and that's where it gets you the rest of it. So rather than having to build like a while true and recursively calling this and passing it the last evaluation key that you received in the previous response, it's done for you. You just build a paginator and it handles all that for you. And then there, I'm just assigning the variables to use the serializers. So I don't want to go through all of the code that I used to get this working, but I did want to cover 2 items. So pretty much I have 4 routes in this entire application. 1 to list all the assets, and then 1 to work directly with a specific item in those assets. And the same for users. So all these are the same in what we're passing. Essentially, we get a request, we evaluate if it has a domain, pass the query parameter. If we don't, bad data, get out of here. If not, it calls a function. So I have 2 functions that the entirety of the logic work off. One that does listing and one that does working directly with an item. And that dictates which endpoint you hit, which function it calls. And the 2 things that I want to cover really fast, I don't want to get into, the majority of this code is really deserializing, working with data manipulation. There's not a whole lot of Boto 3 specific code that I had to do in here, but I did want to show some things I did. So we saw this one earlier. This is just a simple query based off of me getting all my assets. Since the sort key has a begins with method, I can say, hey, I want to get all of my all the sort keys that have a primary key of domain that I've passed in my request, and all the items that start with, and I grab the entity type also from the endpoint that I hit. I'm just grabbing the last part of that URL, and then I'm appending my delimiters there. And that's all it takes to query all the specific entity in that regard. And one thing to note about the paginator is it returns the equivalent of a generator. So in order to get all your items, you're going to have to loop through it. So I just have a list comprehension here that says, hey, I want you to get every item in response and give me back the item's key in that response. The last thing that I wanted to cover, I feel like it's going to be too complicated to get into working with what I'm doing here, but just know this is the thing that I built to handle building an expression that chains all those ands. So what I'm doing here is it's very succinct. It looks complicated, but it's not too complicated. I'm just saying for each key value that you provide me in query parameters, I want you to run it through this function. Reduce is in the itertools library, and it takes a function and a sequence, a list of things, and it runs everything in that list through the function. So really what I'm doing is I'm just building an expression that's chaining together all my key values in my query parameters with an and statement. And that's how I'm dynamically handling when you filter, when you're doing the list. And before we run out of time, I just want to show you how easy it is to work directly with an item. So to work directly with an item for you're adding a new item, deleting an item, and updating the attributes of an item, it just requires a dictionary, which is pretty cool. I like that. So, or at least in regards to putting an item. So here, before I actually start working with an item, I go ahead and make sure the item exists. And if it doesn't, then I'll return you a 404 item, item not found, resource not found. But this projection expression is what I want to show you because I have some code here that looks complicated. But a projection expression is essentially your select and SQL. Tell me what columns or attributes that you want to get back, and I'm building that based off of here it is right here. And again, all of these Dynamo expressions, they want a string, which is not hard to handle, but you have to do some setup because you can't just pass a list. That would be very simple and easy. But essentially what I'm doing is I have a global variable that has all those attributes that I want to see, and I'm filtering it out. And that's solely for the purpose of, if I did not, it would return back the primary key and sort key and things like that, which are backend constructs that the user does not need to know about. And the last thing that I wanted to show was, where is it? Here. So adding an item to DynamoDB with the Boto 3 SDK is super simple. In my regard, based off of the way I have my table set up, it just needs the primary key. It takes a dictionary. That's the part I love about it, where all the other attributes, you actually have to supply a key and expressions and things like that. For actually adding an item, if you have your primary key and your sort key in that dictionary, you can have all the other attributes you want. It just takes a single dictionary and it'll add that. So that's pretty cool. So I'm going to stop there. That's a lot of information. Like I said, it's too much to get into in one 45-minute session. I'm going to post all this. It's already out there on GitHub. I'll post the link in here. But I definitely want to show that there's a lot of setup that I'm doing for Flask type things, but working with the API doing just simple CRUD operations, it's very simple when you're using all these helpers. Right here, these 5 classes make a huge difference in how you can handle that. And the other thing I want to show, Nosql Workbench. This is that application that I was telling you that you can use to build your data models. This is the data model that I built. And I've also added this data model. I exported it, and it's in the GitHub repository too. So if you kind of want to look at the code and compare it to a visualization of the data model, that'll be in there. But yeah, you can work on building your data model. It even I have a secondary index in my particular application, which really is just a copy of my data, but it allows me to sort my change my primary and sort key from the existing data. So the reason why I built a secondary index is because if I look at it this way, and unless I get all my domains and filter, I can't list all my domains without having to provide 1 or 2 domains, because that's my partition key. I built a secondary index that is a copy of my data and it keeps it in sync. And I made my primary key, I changed it so that my entity type is my primary key and my domain is my sort key. So that way I can get a list of all my domains without having to provide a domain name. So secondary index and local secondary index are the 2 types you can do. They both have features, pros and cons about them. I feel like that's an advanced subject to get into, so we're not going to cover that. But I definitely want to show this application. It's really cool, and it also allows you to work directly with your either local or DynamoDB table actually up in AWS. And you can scan it, get all your data. It's really cool. I don't even have to log into the browser to work with my application. So I'm going to stop there. That was a lot of information. Does anyone have any questions, or have I just stirred your brain completely? I'll go with the latter then.
25 bucks to Uber Eats for ever ask a question. Tyron, you want to come off mute?
Let me add this in here really fast.
You can come off mute and ask your question, Tyron.
Okay. How you doing?
Good. How's it going?
Oh, it's going wonderful. I was wondering, can you talk a little bit about the security for DynamoDB, and I'm kind of wondering as far as how would IAM roles work with that.
Yeah, so essentially you can use an IAM policy like you can for every other resource, and you can granularly and conditionally. So you can have your logic of, if you, all the intrinsic functions that you can do within an IAM policy to, can evaluate things conditionally. You can do the same thing for DynamoDB down to the attribute level. So whenever I was showing you here, so let's say this, oh, I'm not sharing. Darn, 1 second. I can find this. Share my screen really fast. Cool. All right, so let's imagine that this is not an application of asset and users. Let's say, well, actually, let's say it is. So let's say for the users, each user, for some reason, had their salary as an attribute associated with them. You could actually, in your IAM policy, you could conditionally limit who could access that particular attribute. So you could get your data back, but you might not get that back. You might not get that returned back to you. So at the attribute level, you could conditionally restrict or grant access via IAM, if that makes sense.
It does. Thank you.
Yeah. That I haven't delved into it. As I was preparing for it, I just read it and I was like, that is insanely incredible that you could do it down to that level. So yeah, I haven't done it myself. I plan to play with it, build some policies and test it. But yeah, it probably worked much like any other resource that you're conditionally allowing access to. And I just added the repo link in the chat. I have pretty much everything in regards to the application stored here, including I can't imagine that you'd want to go build an asset manager on your own, but if you want to look at what I did to get it up and going, I have the Docker file, all the requirements and shell scripts and all the Python code.